This week, my attention was drawn to a Quanta magazine article from over 2 years ago that uses the prisoner's dilemma game theory algorithm to demonstrate how altruistic behavior can actually increase a species survival. And they give two examples. One is the fervet monkey, which you see here, which sounds an alarm when a predator is nearby, which puts its own life in danger, but does alert the rest of the monkeys in the area that there is danger. And the second example was that of a vampire bat, which will feed other members of its population whom it perceives to be not getting adequate nutrition. Both altruistic behaviors are survival oriented. In other words, they contribute to the survival of the species. So anyway, always looking for a challenge in Java, I decided to write a program. Let me pull it up here, which I call a game theory algorithm, and it's much longer actually than it needs to be. But basically what it does, let me just run it here. What it does, it has two matrices. One on the left is neutral, and the one on the right gives fitness benefits to red if red shares. So let's just take a look at what we got set up here. Basically, the neutral matrix has a randomized with equal odds of any of the four choices, a randomization among the four choices. So what are the four choices in the prisoner's dilemma? They are, if both share, both survive, both get a fitness of 0.9. If red defects and blue shares, blue dies, red benefits. If red shares and blue defects, red dies and blue survives. If both defect, in other words, neither one shares, they both survive, but they survive with a lower fitness level. So there are 900 members of this population, and let's just run it for a few things. You can see even in the third generation, what's happened is that there is so much mixing that you can barely tell that red used to be on the left and blue used to be on the right. So the randomization is working well. Let's run it a few more generations, and I'll point out one more thing. What I'd like to demonstrate here or point out to you is how equal the four options would end up being, or how close to each other they'd end up being, because of course we have no bias in the randomization. So here these two are only the red and the blue are only 2 members apart, and these are not too far off of that. So basically that's in only 9 generations we can see that randomization has created a sort of a neutral mix of equal populations among the four. Incidentally, the four are the red survives, the blue survives. Magenta is they both survive with strong, and there's a lot of that, and both survive weak would be the yellow. Okay, over here we get a choice to choose a fitness level, 0.6, 0.8, or 1.0. I'm going to choose 0.8 in just a minute. But we notice that instead of a completely random selection among the four choices, we are giving benefit to sharing, and red is the only one that shares. Okay, I mean red is the only one that benefits from sharing. So if both share, both survive with a fitness of 0.9. If red defects and blue shares, okay, red will benefit from blue's sharing and blue will die. If red shares, and this is the one I really wanted to emphasize, red gets a fitness benefit from its sharing. So it gets a benefit up here if it shares, and it gets a benefit here if it shares, and the benefit will be what we choose below, a fitness choice below. So it's going to benefit one of these three choices. So let's just get started and see what happens. Okay, already in generation 1, we can see that we can clearly see still that red was on the left and blue was on the right, but other things are going on in here. So let's continue the every second all 900 members of the population will go through this algorithm. And as the generations increase, now here we have 14 generations, which is quite enough to demonstrate the point. Sharing with this fitness benefit of 0.8, which I just chose earlier, has definitely given a benefit to the red. And that's the point that this algorithm was designed to demonstrate. And sure enough, with the calculations of all the fitness things for each of the choices for 900 members of the population, sharing or altruism gives a definite benefit to the red. So 6 minutes in, thank you very much for watching.